Welcome back to Zuluba Consultants. In this video, we want to look at how we come up with ionic equations. Now, before we can look at steps that we do to come up with ionic equations, we want to appreciate when do one write an ionic equation. An ionic equation is written when the chemical reaction involves ions to form a solution. So this reaction will show only the changes that is taking place in that chemical reaction. So an ionic equation shows the changes that are taking place in that chemical reaction. Knowing why one should come up with an ionic equation, let's look at the example that we have and see steps that we need to do to write an ionic equation of this reaction. So the question we have that we want to come up with an ionic equation is where hydrochloric acid reacts with calcium carbonate to produce calcium chloride, carbon dioxide, and water. So let's see the steps that are there to come up with an ionic equation of this reaction. The first thing that you should do when you're coming up with ionic equations is to check the question or the reaction that you have if it is balanced. So you need to make sure that the reaction under question is balanced. And do not worry, Zuluba Consultants has produced videos that can help you to learn how to balance equations. So in this one, I'll simply say, if you put a 2 here, then this equation becomes a balanced equation. So I have done the first step, that is balancing this equation. The second step when you are writing an ionic equation is to split ionic compounds. Now this statement raises an important question. How do you and I know which ionic compounds or which compound should we split? There are some guides that help you and I to know which compounds should split. We only split ionic compounds that are soluble to form ions. Now, how do you know that this compound is soluble? When you look at the equation that we have state symbols. So these state symbols help us to know the state in which this compound is. When you look at the first one, that is hydrochloric acid, it has a state symbol AQ that represents aqueous. If a compound has this state symbol AQ, it simply means this ionic compound is soluble. So hydrochloric acid can form ions. This also means that calcium carbonate, because it has AQ, we are also going to split this compound. Calcium chloride also, we are going to split it because it has AQ, which is aqueous. When you look at carbon dioxide and water, the state symbols are gas and liquid. We do not split insoluble substances. In this case, gas, liquid, or solid, these three states, we do not split them to ions. So we only split ionic compounds that are in aqueous. So let's see how we'll split these three ionic compounds that are in aqueous. When we are splitting the ionic compounds that are soluble, we start with metals or hydrogen or ammonia, then we go to non-metals. Now when we are splitting these to form ions, we look at the valence of each atom. Now the valence of that atom tells us the charge of the ion that will be formed. So let's look at the first ionic compound that we have, which is hydrochloric acid. When you look at hydrochloric acid, it has 2 in front of it. So this simply means hydrogen and chlorine will get this number. So we are saying we'll have 2, then hydrogen. What is the valence of hydrogen? It is 1. Hence the charge will be positive. Then we are saying we are adding this with a non-metal, which is chlorine. So these 2 again will come back. Then chlorine. What is the valence of chlorine? It is 1. So it will have the negative 1 there. Now remember the state symbols of this. These are in aqueous state. So this is what we do. When we go to the next one, which is calcium and the carbonate, we start with the metal, which is calcium. So the valence of calcium is 2. So this simply means we have Ca with the 2 as the charge there. This carbonate is a radical, and radicals do not change. So this simply means we'll have this radical shown the way it is. So the calcium carbonate will show the way it is. Now it has the valence of 2 minus. These are in aqueous state. Thereafter, we can go to the products. Again, we'll start with the metal, which is calcium. Calcium there has a valence of 2, so we'll have 2 plus. And then we'll come to the non-metal, which is chlorine. Now when you look at this non-metal chlorine as a small number 2 here, this small number 2, when you are writing the ionic expressions of this atom, it becomes a big number. So when you have a small number of an atom, remember that number becomes a big number when you are writing its ion. The valence of chlorine is 1, hence it will have negative 1. So these are in aqueous. These are in aqueous. Then we said these 2, because there is a gas and a liquid, they do not change. So we'll put this, which is carbon dioxide, and water there, which is a liquid. Those, they will not change. So if you look at this, we have managed to split the ionic compounds into their ions. Now what can you appreciate from what we have done? When you look at the positive charges from the reactant side are equal to the negative charges. What do we mean? You will notice that we have 2 positives here and this positive 2, which makes 4 positives. We have 2 negatives and this negative 2, which makes 4 negatives. So the charges are balancing from the reactant side. So when you are doing the ionic equation, look at the charges, they should balance. When we go to the product, we have a plus 2 there, and these 2 with this negative also gives us a negative 2. So again, the positives and the negatives are balancing. Step 3 tells us that we need to cancel out spectator ions. What are spectator ions, one can ask? Spectator ions are basically ions that are appearing on both sides of our equation. So let's look at the equation that we have. Are you able to see what ions are on the reactant side that are also appearing on the product side? Let's start with the first one. Are you able to see this chlorine, that it is also appearing this side? Are you also able to see this calcium, that it is also appearing this side? So these two ions then qualify to be called spectator ions in this equation. The fourth step after cancelling out the spectator ions is to rewrite the equation removing the spectator ions. So let's see what ions or compounds are we remaining with after we simplify the spectator ions. We can see that we are remaining with 2H plus, which is in aqueous, plus this one, which is a carbonate, which is in aqueous, giving us that side we have a carbon dioxide, which is in gas, plus water, which is in liquid. So this equation then shows the ionic equation of this reaction. So remember the four steps we have discussed. The first one, balance the equation. The second one, split the soluble ionic compounds to form the ions. After you split the soluble ionic compounds, you cancel out the spectator ions. Last but not the least, you rewrite what is remaining after cancelling out the spectator ions. If you do so, you have then managed to write the ionic equation.